it doesn't coincide with the PVI, therefore we need to look for that. We also need to look for the different points along the curve, so the elevations along the curve. That's what we're going to do today. So let's just take a look at this crest curve right here. To determine the elevation of the point on curve, then we needed to know the offset, where offset is equal to a over 200L times x squared. So that's your offset of y. So this is y. So oops. So supposing this is your this curve right here. So the offset would be this point. That's your offset. And but in vertical curves, what we do is we just refer it the elevations from the first grade, so G1. So everything would be somewhere here. So first, you needed to know the elevation of this point, and then you needed to look for the offset, and that's your offset right there. To determine the elevation of the point on curve. Oops, unfortunately, I picked the wrong point. Okay, so the point on curves, it could be somewhere here, right? So any point along the curve can be estimated by using this concept. So first, you wanted to know the elevation of G1 of curve on tangent G1, and then minus the offset. So again, offset is A over 200L times x squared, where x is the location that you're interested in. So let's say I want to know the elevation at this point. So this will be my x. Same thing here. This will be your x. Mm-hmm. Uh,
So A is on the curve, not on the imaginary straight line, right?
the A. A is the gradient, the algebraic difference between these two grades, G1 and G2. But the elevation on tangent is along the grade 1, this grade. And then you just extend this line here. So it's like an imaginary line being extended here. And then you need to look for the value of y to determine the elevation at point x.
So excuse me.
Joseph?
Yeah. So the y offset is only at when you associate with x, right?
Yes.
And does it and can the offset y can be anywhere on that line?
Y can be not can be anywhere, but it has to correspond with your x value, right?
Okay.
Yes. Mm-hmm. But the reference point is always G1.
Mm-hmm.
So first you needed to know your x, right? Then the value of x. And x can be, this would be the, x here represents the highest point on curve. And so we're trying to find that. And x is equal to LG1 over G1 minus G2. So this is how you would determine the highest point on curve. Similarly, if you wanted to know the lowest point on curve, let's say x here. So the lowest point could be anywhere here, right? So in order to determine the lowest point, again, you try to find x using this equation right here. And x is always based from the BBC, the beginning of the vertical curve. So the reference point is always the beginning of the vertical curve. So that's how you'll find x. And then the y prime here is simply your this one value here. and that's equal to g1x over 100 minus ax squared over 200L. Okay, you'll need this to determine the elevation on the curve. However, on surveyor's notes, it's always the way they tabulate it is you'll have the elevation of the vertical curve and then the elevation on grade at various stations, and then you just subtract it by the offset. So it's better to just concentrate on this one because that actually the G1X is this right here, and the offset is that. So this will help you determine the elevation on the curve. Now the y height, this represents the highest point, the y with the respect, I mean the highest point on curve, right? So to determine the y value for the highest point, only for the highest point on curve, it's equal to LG1 squared over 200 times G1 minus G2. Similarly, you can use this to determine the lowest point on curve. So again, same approach whether you're talking about the highest or the lowest point. So again, it's 2 here.
What did you say? You can find the highest and lowest with what?
Yes, you can find the highest and the lowest point on the curve right here. So where is the lowest point? So you'll use the same equation right here, and we'll apply that so it will be clearer as we go along. So the curve elevation is equal to your tangent elevation minus the offset, which is what we have here, right? So tangent elevation minus the offset. Now let's just take a look at this problem here. So and see how we can apply that.
So what
So
I'm
again,
doing is I'm
this is
recording
a
it,
crest
and then I have to
curve
figure it
right
out. I
here,
can't just be
right?
like, oh,
Crest
okay, I'm
curve.
just gonna fail this class.
And
you know,
because
you can't do
there's
that.
an even grade here, so the PBI does not necessarily correspond with the highest point on curve. So the highest point could be somewhere here or somewhere there. So that's what we need to find out. So this one is your 4% right here, and this is your minus 2%, right? So first, to be able to okay, so first we need to know the length of curve. So how do we solve for the length of curve? So this is your crest curve, right? So let's try doing that first.
Where? To buy a notebook. Right here to the North Gate. That's not too far. The North Gate must have notebooks. Like a little
Which equation shall we use here? Okay, let's try doing that first. So this is a crest curve, and we have an equation for S less than L. I like to solve using S less than L first because the equation is shorter, and oftentimes this is the one that will give you the result that will satisfy the requirement.
You might as well walk her while you're at it.
Do you not have cash?
Where's my bank card?
Last time you used it was on what?
On what?
Last time you used it, what was it on?
When we went for
Well, how much?
Try to keep looking for fucking hello.
we went for shade it must be Charlie. Oh, but we gave up Charlie.
Then we claimed Charlie too. Some puppy or rugby. Look up in. I'm scared. Jenny because the phone is on. That scared me.
go? How are we gonna go?
So we know A, that's 4, and 2 is 6, and we have to solve for S. Oh, that's
Let's take my phone.
an additional step. So what is
Apple Card doesn't
S?
work still, huh? Damn it. I'm gonna have to go with you. Mira que me despertó. Hi, mama. Hi, chiquita. Hi, mama. Hi, mama. Hi, baby. Hi. Oh, she's scratchy. The princess is scratchy. The princess is scratchy. She is a baby scratchy. You're so cute. You're so cute, mommy. You're so cute. You're so cute. You're so cute. Papa, you will love me.
S is
I got 147.8 feet. Is that right?
400,
Oh no, 147. 147.
147. Oh, that's the S. What's that? The S?
That's the S.
Okay, it looks small.
Too small? Okay.
Yeah,
So
I
I
got
did it wrong.
565.5.
565. Did you just 0.35 minus 0.02? Doesn't look like it.
I'm gonna get you.
All right. I got 584.1.
Yes, so 584 is what we get. So here you'll use G is minus 142. So 584.
You got saved. I don't have one. I'm gonna have to go with you. Sister, there has to be something. Check if there's an available folder. There has to be something.
1. So 584.1. So you can solve for L. You can't access the lecture notes on Beachboard?
Here.
It's not on Beachboard. Let's check.
There's this one.
Did I thought I put it in.
I'm gonna get you. I'm gonna get you. I'm gonna get you.
Horizontal, it's right here, vertical curves, no?
I'm gonna get you. Here. Use this notebook.
When you click Professor, it says files associated with the content topic cannot be found.
Hey, take her out of my house.
Oh, what happened?
So there's been apparently a glitch in Beachboard, and they said that you have to delete that file and then re-upload the file again.
Okay, so it's a glitch. Hold on, let me just erase it.
Hey, you have to cuddle with me.
So hopefully that will work. yes. Now it's working. Thank you for letting me know.
Oh, you know the activity 4 that you also submitted?
Uh-huh.
It also doesn't work.
Really?
Yeah, activity 4.
Okay, contact. Thank you for letting me know. Otherwise, let me check.
Let's go to walk. You want to go to walk? Let's go to walk.
Yes.
Let's go to walk. Okay, let's go to walk. Go. Go. Let's go to walk. Come on. I'll be off. This way. Go, baby. You got it. 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 Go.
Activity 4.
Look at her. That's so cute.
That's the activity associated with this lecture. Okay, so you're able to get the answer for this? Let's see.
Scary.
Oops, what have I done? Okay, so what did we get here? So L is equal to,
Your focus to right here, baby. Let me see, Papa. Let me see, Papa. There you go. This one goes to right here. Where this goes to. This goes to right here. Okay. Let's go. Careful.
Sorry, what is that symbol before the S square?
A.
A?
A. The difference in grade, algebraic difference in grade.
Why you sit down? Let's go.
The equation you used for SSD was the 1.47 times U times T plus U squared over or whatever.
Yes.
I can't get that 584 number.
Okay, let me write it here.
Sit. Come on. Sit. Sit, Mia.
SSD
You sit right on the
equals to 1.47
Let's go.
dt, right?
Let's go. No. Sit. Sit.
Plus
Sit.
d squared over 30
Bye bye.
times 0.35 plus g.
Oh, okay. I see
So
that.
here we have,
I
yeah.
mixed up those numbers. Okay.
So you put plus probably.
I put the 35 on the outside and then the 30 on the inside. Okay. Switch.
Okay. Don't forget the 2.5 here. That's the time. And plus 60 squared. Over 30 times 0.35 minus 0.02, because that's the critical one. So that will give you 584.1 feet. So now substituting the value of S here in this equation, we'll get L is equal to
And it gives you 948.6 feet.
900. Okay, so 948.6 feet, right? 948.6 feet. Let's just round it to 950 feet. Okay, so let's say 950 feet. Okay. Let's do 949 instead of 9. Erase. I'm sorry.
So you round it down to.
Let's just round it to 949. The whole number. Okay, so 949 feet. So that will be the length of our curve, right? And now we wanted to know the station and the elevation of BBC and EBC. I said this is just like a review of last time. So what's this? The elevation of BBC and the station of BBC and EBC. So please try to solve for that. Okay, let's see. The station of the BBC, this is 900, did we say 949? Okay, 949. So this is the station of BBC, station of EBC, and this will be what? So who has the value for the station of the BBC? Station of the BBC is equal to the station of the PVI minus L over 2. So that will be station of the BBC is again station of your PVI minus L over 2. And that will give you station 15 plus 25.5. So that will be your station. What about the elevation of the BBC? Elevation of the BBC is equal to, again, this should be lower, so 500. I'll put the 100 here. So that will be okay. So now we can okay. So we got 490.51 for the elevation of EBC. Did all of you get this value, or is there any question on this?
Professor, I have a question about the elevation of EVC.
Yes.
Yeah, so
Of
the value,
elevation. Okay.
yeah, the value that I got was for G, do we do it as negative or do we still have it as positive? Because when I did it, I input it as positive, and I got 509.49, which is not.
Oh, okay. So it should be lower, right?
Yeah.
So if you're getting a higher value, that means there's something wrong.
I mean for EVC. Oh, it should be low. Yeah, right.
It should
That
be lower,
Oh,
right?
yeah, right.
The elevation. So
Yeah, so we put it as negative, right?
yes.
Oh, okay.
So here, this is a positive 4, so you subtract. So you subtract it.
Yeah, okay.
Uh-huh.
Yeah, sorry, I got it.
Yes. Yes. So when you're solving curve problems, just take a look at the value that you get and then what you expect. So if you expect it to be lower and you get a higher value, then there's something wrong. So even if you don't remember what the equation is. So both are negative. Which are negative? Oh, here. So minus G1 over 100 times L over 2. So you subtract because it's supposed to be lower. The elevation is supposed to be lower than the PVI. Same thing with the EVC. So here we add, right? Because minus will give you a positive. Plus minus will give you a negative. So it's going to be lower again. Is there any other question? Thank you for those questions, Osman Mason. So now we get that. It's important to establish this because that will be our next step. Our next step would be to determine the location and elevation of highest point on curve. So this is the location. So location of highest point. I'll just put X high, so that's the highest point. So X high would be equal to, so here we have X high is equal to, so we have that equation here, which is LG1 over G1 minus G2. So that's how you determine your X high. So LG1 minus over G1 minus G2. So LG1 over G1 minus G2. And that will give you your X, the location of the highest point. So here we know L, 949, we know G1, 4, we know G2, which is minus 2. So you'll have 949 times G1 is 4. I can put 100 here, but eventually I'll be canceling it, so I can just ignore the 100 there. And G1 here would be 4 minus 2 over 100. So all of this cancels out. So I can just write 4 minus 2. So 4. So how much did we get here? So 949 times 4 divided by 6 will give 632.67. So 632.67 feet. So that's the location of the highest point on curve. So that's at 632.67 feet. So this will be the value of x. So now the station would be the station of the BVC, so always with reference to the beginning of the vertical curve, plus x. So that will give you, how much is that? 632.67 plus 1525.5. So 1525.5 plus 632.67 will give you 2158.70. So 2158.17 or 21 plus 58.17. Okay. So, is there any question on this, the highest point? So again, just use this expression to determine the location of the highest point. Now, the next question is the elevation of the highest point. So what's the elevation of highest point? Or I'll just call it LX. LX high. The elevation of that point. So what is that? So to determine the elevation, first you need to know your Y high. So Y high Y high is equal to Y high is equal to LG1 squared over 200 times G1 minus G2. So again, LG1 squared over 200 times G1 minus G2. So here, we know L. How much is L again? L is equal to 949. So 949 times G1 squared is 4 squared over 200 times G1 minus G2, which is, how much is G1? 4 minus 2. So that will give you 12.65. So now that's our Y high, then you can determine the elevation. So elevation of Y high, elevation of X high is so elevation of your BBC plus Y high. So elevation of the BBC plus y high. This is for crest curve.
Sit. Sit. Sit.
The elevation of the BBC is 481.02, so we add 481.02
I'm trying to teach her how to wait, but she don't want to
plus
She wanna
12.65.
go for it. Sister, you left something on the stufa. Sister, you left something in the stufa?
Yeah, the carne, no?
So that
Still
will
not ready?
give you 493.67.
She's a thirsty bitch. Oh, shoot. Oh, no. It's fine.
Okay. Is there any question on this
Go
one?
inside. Hey, go inside now. Yes, sir. Yes, sir.
Okay, so what have we done here? So after establishing our BVC, EVC, and the length of curve, then we try to determine the highest point, the location of the highest point using this equation. And we said that it's 632.67, so which means the highest point is somewhere here, right? So the highest point is on the right side of the BBC. So that's on the right hand side of the BBC. So somewhere here is your highest point. Now, we needed to, okay, it's at 21 plus 58.17. Then to
Hello,
determine
Helga,
the
how are you?
elevation of the high point, the highest point,
Hello?
then we use this equation,
Hello?
y high, which is this
Yes,
y.
I can hear you. Hello, Helga.
Okay.
Yes, I'm here. Can you hear me?
So this is your
Can
y
you hear me?
high.
Hello?
And that's up to the curve only. Oops, I erased the wrong one. Oh no, I erased everything.
I control Z.
Okay.
Control Z. Control Z. Control C. It doesn't work.
Uh-oh.
Okay. So anyway, so that's how you determine your y high. So y high is this point. Okay. That's your y high. So and that's 12.65. So the elevation of the BBC plus y high will give you the elevation of the highest point on the curve. So we're talking about the curve, not the tangent. So the curve is here. So again, elevation of the BBC plus y high, right? So elevation of the BBC plus y high will give you the elevation on the highest point of the curve. Is there any question on this one? Okay, so next, we can verify if this value is correct using the offset. Okay, let's just go to another one. And the offset would be, okay, let me just draw the curve again. Oops. Yes, so the curve is somewhere here, right? I mean the highest point. Right? Yes, so this is where the highest point is. Let's just say this one right here. And that's your X. So using the concept of offset, what it says is first you needed to extend the curve, the tangent, up to here. So we're extending the tangent. And we wanted to know the elevation at this point. So elevation here. Tangent X. I'll say X, or point X. And then we'll subtract this
of
one.
course. Yeah, we had already scheduled one for tomorrow.
And that's
The
your
reason why
offset.
we scheduled the one for today is in case that we don't finish reviewing for the test. We still have tomorrow morning available. But we can try. I mean, we can try
So
and squeeze everything.
the
way that
elevation
this
of
we
the
do it,
highest
we prepare
point
for the
will
test.
be
We have a
equal
set
to,
prepare
it's
for
the
the test.
same as
And
elevation of
if we
the
don't
x
finish
high
in the time frame, then we see each other the
would
morning of the
be
test to create our cheat sheet.
the elevation of
Basically,
any
our study
point
guides
along
for
the
the
curve.
test. So that's why we scheduled the morning
So
one.
here we have x high is
Prior to the
equal
test,
to
tomorrow's session.
elevation of the BBC again,
Yeah. I do.
plus the elevation on tangent, which is this one, g1x over 100.
We could do that.
Oops,
I agree.
this should be g1, the big G. Minus the offset, minus y. Okay, so first we try to determine the elevation on the tangent, and then minus the y will give us the elevation on the highest point on curve. So it's the same thing, right? We're referring to the same point. On the first one, it's BBC plus y, which is we just added it. Y prime, the y high. So here now, this is what we wanted to know, the offset. So offset is equal to how much? So y is equal to ax squared over 200L. So that is your offset. And that's derived from the parabolic equation, parabolic curves. So ax squared over 200L. So A, what is A? We know this as 4%. This is minus 2. So A is 6, right? And how much is X? We found X earlier. How much is X? So X is equal to 632.67. So 632.67 feet. So we know that we can substitute it here, 632.67 feet over 200. And we know L, right? L is how much? L is 949 feet.
Oh, don't forget to square the x.
Oh, thank you. Thank you very much, Joseph.
Really?
So 943
You're a bad walker. That's not walking.
and 949. Okay.
Let
So
her off,
now you
please.
can
Have her
solve
catch
for
her
that.
there. Let her go. No, not off it. Let it, because then you're not gonna be able to catch her. Yeah. But just watch her. Or bring her back inside. Bring her back inside. Or bring her back inside.
So you got
Just make sure she doesn't jump on anyone. Make sure she doesn't jump on anyone. Yeah, but then she's just right there.
12.65 feet, right? So now you can determine the elevation of the highest point, and that's equal to elevation of your x high is equal to the elevation of your beginning of the vertical curve, which is, how much is that? I forgot. 481.02. So 481.
What are you working on? Are you working on your math out there? You're lying. You're on Instagram on your computer.
0.02
Come finish your work here.
plus G1x. How much is
Bring me out. I'll go
G1x?
watch her right now.
That is 4
Yeah, get it done right now.
times 632.67
I gave you the notebook.
over 100 minus offset
Oh, and you have to eat too. You have
minus
to eat anything.
12.65 feet. Will give you 493 point. How much did we get? Should be the same.
.67.
0.67?
Yeah.
Yeah, so we got 493.67 feet. What did we get earlier? 493.67 feet. So that's one way of determining whether or not your calculation is correct. But this is a long way, right, to determine that. So here we applied the concept of offset, so to determine the elevation of highest point. So what it is saying is the elevation of the highest point right here would have, I mean, you can do it two ways. Either you add this y here,
Fresh to go do workout.
right?
It is. I mean, if I
Which we
trusted you that
obtained
you would do your
earlier,
homework,
That's
or
why you don't even have
you
your notebook.
subtract
I told
the
you to do all your
offset.
work
So
in the
that's
notebook.
two ways of solving it.
I'm
The
not
other
asking
one
you.
is
You're gonna
shorter,
do it because that way
but
you can
this
refer
one
to
is,
it when you don't know how to do
far
something.
better compared to the first one, because you can solve any point along the curve using this concept. So now, let's just take a look at the next problem. So it's asking for
Grab something to eat too.
the elevation at
Grab
station
something to
22 plus 50.00. So
No,
how
you
shall
haven't
we
even
solve
ate.
that problem?
What did you eat?
22 plus 50.00. So here, elevation, what's number B? At station 22 plus 50.00. So we wanted to know the elevation at some point along the curve. So here, we can use this procedure to determine the elevation. Okay, so first we solve for x. How much is x? Again, we'll know x because we know the exact location. So that's 2250, right? Minus the station of the BBC. So what's the station of the BBC? The station of the BBC is 1525.5. So 1525.5. So that's the value of our x. So 2250 minus 1525 will give us
What PBM?
724. Yes, 724.
Wait, do I just warm this food up? Do I just warm it up?
Yeah, it's good. I don't know about the spaghetti though.
Bruh, sister. I like the spaghetti.
Yeah, but there's more spaghetti inside.
So I just throw that one away?
Yeah.
Is there any question on this, how we found x? So again, x is simply your station minus the station of the BBC. So next, we wanted to know the elevation. So again, elevation on x would be equal to the point x is equal to, here we use the same concept, elevation of BBI, BB should be BBC. Plus G1x over 100 minus y. So we wanted to know what is y. So y is equal to your offset ax squared over 200L. So how much is that? We know x, 724.5 squared multiplied by a times 6 divided by 200 and divided by 945. So we're using the denominator. So it will give us 16.59 feet.
Professor,
Like
Yes.
30?
can you show the
Seconds?
page with the calculation for the station BBC, please?
This one? Okay. So the station of the BBC is equal to, station of the BBC?
Yeah, I think it was just a page of calculation before this one.
Sorry. I think it's
Yeah, right here.
of the BBC.
Go ahead.
That's right. Okay,
Yeah,
thank you.
but I don't think it's ready.
Sure. Why did I erase this one?
It's not ready yet.
Okay. Anyway, that is your station 2250 minus station of BBC. Okay. So now y, we know the value of y, and that's 16.59, so we can determine the elevation at point x. So at station 22 plus 50, and that's equal to elevation of your BBC, which is 481.02, and we add that certain value here to get to elevation on tangent x, and that's equal to plus 0.04 or 4 over 100 times tangent times x, which is 724.5. Minus 16.59. And that will give us, okay, so 481.02 plus.
You got 4?
Yeah.
Minus 16.59. 493.35. Okay, so is there any question here? So first, again, we needed to know what the value of x here is with respect to the BBC. So we get 724.5. Knowing that, you can calculate your offset. So y is ax squared over 200L is 16.59. Then we solve for elevation on at station 22 plus 50, and that's equal to the elevation of the BBC first, and then we extend that to the tangent right at this point. So elevation on tangent at station 22 plus 50, that's this one, 4 over 100 times 724.5. Then we subtract the value of y. So again, the concept is, first you need to notice elevation, right? And then you subtract the y offset, so y. So this is the known elevation of the BBC, and then you need to know this one, and then you subtract. So it's always plus, so you can go up, and then minus. So plus, minus. This is for crest curve. So this is plus, this is what we have here, and then minus y. Any question on this? Okay, then let's try solving another problem. This time, let's apply it on a sag curve. Again, the same concept will be used, except that now we're dealing with the it asks for the length of the curve, right? Is it?
Just telling you to hurry up.
Let's see what's given. Maybe there is an easier way. Okay, elevation PVI is given. Elevation. I missed something here. It should be station. Okay, let's add another problem, another info here. Station of the BBC is given.
Mia. Here, baby. Mia.
Plus 0, 0. Okay, this is important information, so please note this one. Station is given at 16 plus 0, 0, then determine the length of curve. So that's what we will try to find out now. It will determine the length of the curve. Okay, so how shall we do that? Is the blackboard? Okay. So what's given? Again, minus 16. So this time we'll draw the curve, and it's a sag curve like this. Oops. Anyway. So 16 plus 0, 0. So this will be known as 16 plus 0, 0. That is given as 19 plus 0, 0. The elevation here is given as 600. So what's the length of the curve? That's the first step. So length of curve would be equal to, you can give the value. Okay, let's see. Okay, no volunteers.
Yeah, get inside. Get inside, baby. Go eat. Go eat.
What's the length of curve? G is given, right? It should be given. Minus 3 and 2. Okay, so minus 3. And 2%. Okay, so how do we solve for the length of curve? Can we solve it?
You right what the speed was again too?
Oh, okay. The speed is given as 70 miles per hour. But in this case, let's we'll just use whatever is given here. So this is the actual length of the curve, and that's equal to 19 minus 1600. So here we'll give 1900. Okay, 1900. So in case you are given this information like this, the step to determine the length of curve is to just subtract your stations. So station of BBC.
So is it 300?
Yes, exactly. PBI minus the station of your BBC. That's L over 2, right? We know that's at L over 2. So this value is only L over 2. So you can solve for L. So L is equal to 300 times 2 or 600 feet. So 1900 minus 1600 multiplied by 2 will give you 600 feet. So this doesn't necessarily mean it satisfies the minimum requirement. Which you can find using the long equation, which is calculate your S first, SSD, and then calculate the minimum length based on the ASTO requirement. But for now, this information is given. So this is the actual curve. So the length is only 600 feet. So now, knowing that, the next problem is compute the elevations of the BBC and EBC. And then the lowest point, elevation of the lowest point, location and elevation of the lowest point. So elevations of the BBC. So what's the elevation of the BBC? So who can give the value for this?
Hey, in your blanket.
So 600 minus or plus, right? So 600 plus
In your
0.03
blanket, remember?
times 300.
$609.
Yes, thank you very much. 609 feet. So that's the elevation of the BBC. And what about the elevation of the EBC? What about the station of the EBC? Let's try that first for completeness. So elevation station of the EBC is equal to station of your PBI plus L over 2 again, right?
It's 606.
L over 2. It's 606. We're talking about the station, not the
Sorry, my bad.
22.
Yes, so 19 plus 3, right? So that will give you 22 plus 0, 0. Yes, then the elevation of EBC is, you gave the value earlier. Is it Joseph or was it Joseph?
Me, yeah.
Yes. Yes, so the elevation of the PBI plus G2, right? G2 over 100 times L over 2. Or did you say 609? Or 606, right? So that 606 feet is the elevation of the EPC. So now, what is still being asked? Determine the location and elevation of the lowest point. So what is the elevation? What is the location of lowest point? So first we need to solve for x, right? So x low is equal to, again, we'll just use the equation that we had earlier, except that this time we're dealing with low, but still x is LG1 over G1 minus G2. So here we have LG1 over G1 minus G2. So how much is that?
$360 feet.
360. Yeah, that's correct. Thank you. And then we can solve for the elevation. So elevation would be, so first we need to know the Y low, right? So what is Y low? We'll use the same equation, but this time instead of high, we put low. So LG1 squared over 200 G1 minus G2. So LG1 squared over 200 times G1 minus G2. And that will give you so L is 600, right? How much is this? It's minus 3 minus 2. Right? So that will give you minus 5.4 feet. So now you can determine the elevation of the lowest point and x low, and that's equal to your elevation of the BBC.
I got positive 5.4.
You get positive.
Because it should be.
Yes, so this is positive and this is negative, so you get negative. Elevation of the BBC plus Y low. So elevation of the BBC, we know that at 609 feet. So 609 feet minus 5.4 feet. And that 603.6 feet. Yes, is there any question on this one? So supposing, just like what you did earlier, was it, George? You got 5.4, right? You gave me 5.4. So
I figured out why I wasn't negative.
yeah, but supposing you forgot the sign, it's fine too. But just make sure that when you do the subtraction, or whether to add or subtract, just look at where your BBC is and look at where the lowest point, and you know more or less what to expect. If it's going to be a higher or lower. So in this case, you have 603.6 is the elevation of your bottle. Is there any question on this? Now, the next problem, I think, asks for the elevation at station 20 plus 00. So, and then the other one is, does the curve satisfy the minimum length based on side distance? So that's, again, the question wherein you need to know if the length of curve is okay. So these two, we'll try to look at this on Thursday. Meanwhile, maybe you can just try solving this at home. And the activity is also posted, so please take a look at that. And if you have any question, we can discuss it on Thursday.